Standard 3.1 meets. I can use a velocity time graph to determine the acceleration of an object. For this problem, the most important thing is that we know that on a velocity versus time graph, the slope of the line is equal to the acceleration. The reason that this works is when we take the slope of something, the equation that we use is y2 minus y1 over x2 minus x1. This is like saying we have our y units over our x units. This is like saying meters per second, which is really meters per second squared, which is ultimately the unit for acceleration. So now, in order to solve this problem, we need to take the slope of both the A and the B segment. To do that, we want to find some data points. If I'm going to take the slope of A, I'm going to use 0, 0 as a data point. I'm also going to use 3, 30 as a data point. So for A, I can take 30 minus 0, those are my y points, divided by 3 minus 0 to give me 30 over 3. If I divide that out, I get 10, and I want to include my units, meters per second squared. So for A, 10 meters per second squared is the acceleration. For B, you could do this two ways. You could use 3 and 30, and you could use 10 and 30 and plug them into your slope equation. Or you can understand and remember the fact that a flat line doesn't rise. It has no y, therefore it's a 0 divided by something. We've talked about slope as also being rise over run. This has a run, right, from 3 to 10, but it doesn't have a rise. When your rise is 0, or the numerator of your fraction is 0, you can't divide it by anything, which means for B, we get a slope of 0 meters per second squared, right? Again, that slope is your acceleration. So for A, you have an acceleration of 10 meters per second squared. For B, you have an acceleration of 0 meters per second squared.